don't have an official one yet, but everyone is welcome to help build the official one. So we are on top of the hour. I think we can start the meeting. Welcome everyone to this IETF 111 session for the core working group. I am Marco Tiloca, my co-chair is Jaime Jimenez. We assume people in the audience to have read the documents presented today. We need to make a good use of this time to advance the work. The note will also summarize in the next slide applies. We are on Miteco, so blue sheets are collected automatically. There's no official job described, but the chairs will keep a look in the chat. And we have a note taker for today. Bill, thank you very much for accepting. Everyone is welcome to help out Bill to take notes. And this is an official IETF meeting, so the note well applies. Be sure to be familiar with that. It's not only about IPR, it's also about our code of conduct, so be nice and professional with one another. A few practicalities. Since we are Miteco, please request to enter the queue using the leftmost hand icon, or if you really need a request to relay your comment at the mic by someone of the attendees. This meeting is recorded as we speak, and again, attendance is collected automatically as blue sheets. Also today we are using the new features for Miteco that we've just tested about presenting PDFs directly for the speakers. Right, this is the agenda for today. We meet only today at this IETF meeting for a 2-hour session. We start with the HRF document led by Karsten. Bill will join to present the ongoing work on DNLink and conditional attributes that was split into 2 drafts. Christian has a slot on transport indication, also discussion oriented. John will present a revived document on co-op attacks that bridges into a kind of second segment of the agenda, more on group communication and security. So we take group communication for co-op, group score for its security, and a number of more recent works differently related to OSCORE. Any bashing to this agenda? Anyone? No? Then a quick recap of the recent updates to our documents. First of all, we have recently published RFC 9030, used to be Core Dev URN. Thank you very much indeed to the working group and the authors for this nice achievement. We have a number of documents in a very advanced stage in the RFCQ, resource directory in new block in misref, waiting for echo request tag that should also enter the same stage pretty soon now. And SNML versions enter out 48, I think yesterday. We have a number of documents in ISG processing where echo request tag technically still is, or at least there's an announcement to be sent, but the authors resubmitted a version before the cutoff, and now it's technically back to an AD follow-up stage. And of the 4 CoreConf documents, 2 were requested for publication. We got tons of good comments from the ISG. They are now under revised ID needed, and since Karsten joined the author list of both of them, the shepherding was transferred to the 2 chairs. We also have a few documents in post-working group last call. We actually requested publication of SNML data CT. Then we have the other 2 CoreConf documents that have to kind of proceed in parallel. COMI requires both some editorial fixes and technical clarifications. Authors are on them. Young library has basically to follow. And then we have the group of score document that passed the first working group last call. There has been major updates to that. I'll come back to that in a later presentation today. And then we have one more point that we thought of raising here at this meeting with you. The chairs have recently discussed about a possible update to the working group charter, since it is now pretty old and outdated with respect to what we actually did already, what we are doing, what we might have in the queue to do. And the main motivation for this is that charters are now looked more and more closely by the ASG when receiving a document. So we would like to be on the safe side about that without needing to interpret too much what the charter says, and that we are actually in the right. And clarity is also a benefit for potential newcomers to better understand what our work consists of. So it's not at all about any major drastic change of direction, we hope. We'd like to keep the same overall scope and track, but at the same time, it's good also to update the description of work so that it reflects faithfully what we actually achieved already, what we are doing, and what we plan to do building on that. So the first step, of course, would be for the chairs to prepare a first draft of the updated text to share with the working group. And that will be followed by joint revision on the list, and also using some time and the interim meetings we have during the autumn. But of course, we wanted to hear already today some early thoughts or objections against this. Does anyone have a comment? Karsten?
Just comment that we do these charter updates when we have to. So yes, these are all reasons, but then the wheel we need to turn to do this is pretty large. So yeah, unless we have a really good reason to touch it, maybe every 10 years or so.
It's not going to be the very second version. It was updated before, but sure, it's a delicate step. We need to take it carefully. Any more comments, anyone? Silence is good. Then we'll take the next steps and come back to you with this. And we can actually start with the first item in the agenda, which is Karsten with href. So I relinquish the sharing. The floor is yours.
Have worked. So
yes.
in case people want to see that my hair now really looks like my gathered at town avatar. Yeah, I want to quickly talk about the CRI draft, which is called href, and I have 13 slides to do that in 10 minutes. So this will be very brief, but if you have a question, please do ask it. So basically, when the web was invented in 1990, there were three big components: the URI, the HTTP protocol, and HTML. And we know that this continues to work today, 30 years later. And when we did the thing web, or our version of the thing web that we call core, we left the URIs in place. We did a new transfer protocol, and well, we have several representation formats in use, some of which are CBOR based, some of which are not. And so we have a little bit more diversity there. Yeah, but well, maybe it's time to look at the URI part, because that's really the oldest part in the combination again. And this is essentially what this href draft is about. href is just an abbreviation for hyperreference, because we couldn't agree on a name for the CRIs, but I think that has been mostly settled now. So what's the reason why we want to get rid of URIs? Well, Klaus has put down a sentence in the document that pretty much describes it. There are lots of implementations of URIs, and they are all wrong, and they are all subsets. They're all are non-interoperable in some corner cases and so on. And the main problem is that it's really not trivial to transform between the URI syntax and the data model that we would actually need. So just to remind everyone, RFC 3986 is the URI RFC, and that tells us the URI has 5 components: a scheme, an authority, which is hostname plus other info, port number. We have a path, which is composed of path segments. We have a query, and we have a fragment. And when we designed CoAP, we actually mapped these components onto CoAP options in a way that CoAP server, in the best case, only ever sees parsed URI. So we already did kind of the work that the general CRI document is now trying to do, but that's work that's just for the transfer protocol. And some of the issues that URIs need to address go beyond the transfer protocol, because we want to have them in the resource directory and so on. The other part is, in a data at rest in a document being interchanged, we also want to support URI references, which are partial URIs, like in the left column of that table here. And there are resolution rules in 3986 that are, well, interesting. So it's really unlikely that the random URI implementation that you find somewhere completely implements the whole resolution procedure. It's that complicated. So that's another part of the problem that we are seeing. And relative URIs are really useful to make documents independent of where they are located, so that you cannot just get rid of it and say, let's do all absolute and lose this complexity. So what are CRIs? Well, CRIs are essentially a new representation format for the same old URI data model, a little bit constrained. So that it's not, you cannot put user info or other parts into a URI, from a URI into a CRI, because we really have learned why we don't want to use them. But for practical URIs you would find in an IoT environment, CRIs are going to cover that. And not just in an IoT environment, there are also other environments that might want to use it. So Draft IETF Core href defines CRIs and CRI references in a modern representation format. So it's no longer text-based, it actually has the components identified in a structure. So we worked on this for a while, and then we finally had -04, the new syntax branch in the GitHub repository, if you have followed that. And that contains a number of suggestions from Jim Shard, a little bit optimized. So this was a very efficient form to write down CRIs, but also a form that requires a number of decisions, a number of parsing steps during ingestion. So the abstract content here is that we take the 5 tuple that URI is and add a 6th element to support URI references, that is card component, and that's essentially all we need. And path and query are arrays, and authority is sometimes an array in that version of the document. So that worked, but yeah, it was maybe more complicated than we like in a constrained environment. So in -05, we took away the syntax that needs to be parsed, and essentially directly used the 6 tuple, albeit in two compacted variants. So these variants are essentially the absolute URI and the relative reference with a few corner cases that straddle that boundary. So it would not be correct to talk about absolute and relative entirely. It's just two different syntaxes for the information. So this simplification is particularly expensive for relative CRI references, which might get 2 to 4 bytes larger. Otherwise, it's for absolute URIs, it's pretty inconsequential. It just makes ingestion simpler. Then we implemented that and kind of liked it, but we found 2 places where we actually wanted to make a change. And one is something that needs to be fixed because URIs can be something like a URN, which doesn't really have a path, but an opaque component, which can be thought about as a single path component. But the interesting thing is that UN:eggs and UN:/eggs mean 2 different things in the UI syntax. So translating them both to the same CRI means that CRIs cannot reflect that detail. So we didn't really like that, but we came up with one way of handling this anomaly. So given that these all are depending on the fact that there is no authority there at all, once you have an authority, you no longer have this anomaly. We just use the authority field, which is the second field here in the tuple, to indicate this is an opaque that doesn't have a slash, so that's what the true says. So this is not beautiful, but it kind of completes the picture. The other observation is that the syntax of host names itself is something that we might want to relieve the participants from parsing it. -06 proposes to actually parse the host name, like in the UI at the bottom of the slide. We have tzi.de, and this is coming as an array with the 2 components, tzi and de, plus another component, which is a number, which is the port number. This is essentially a way to do the same thing Corab would have done, except that we didn't really think we needed to optimize the transfer of host names here, so we didn't do that. So this is one part that can be undone if we don't like it, but -06 currently contains this version. So that's the technical part. The status is that we think we now have a consistent design. We think the design is feature complete in the sense that everything that you want to have in a UI can be covered, but at the same time processing CRIs is much simpler than processing UIs. And what we need to do is fix our implementations to be entirely compatible to what we describe in -06 and publish those implementations. So we didn't manage to do that before the IETF. So that's the status of the document and its implementation. We made one more change. The href document was originally developed specifically to be used in Corel. The main author was Klaus Hartke. And Klaus is a little bit taking time off from Corel right now. On the other hand, we have a requirement to push forward CRIs from other groups who want to use CRIs in their CBOW formats. So we decided that we will try to finish this within a finite amount of time and appointed 2 finishing editors, one of which I am. So my outlook here is that we need a couple more reviews from people who have implemented this, and maybe a few more things we want to streamline here. And then we should be ready for working with Blast Call, preferably before 112. There was a question from Thomas Fossati. Can you tell more about what is the use case for passing domain name labels? Well, what I didn't say is that actually, of course, not all authorities contain domain names. So you would have an IP address here in many cases, an IPv4 address or an IPv6 address. So the previous version just has a type choice between those IP addresses and a text string which conforms to the reg name property that is defined by 3986. And the observation here is that having to parse these DNS names is a little bit out of character from the rest of CRIs that actually parse everything down. So you except for the equal sign, which is a thing on its own because it's not always present, you really see the components. And for instance, you can construct DNS queries right from the components. So you don't have to pull them apart to do a DNS query. But I cannot say there's a use case that absolutely requires that. This is just trying to make the whole thing look consistent. This is not something that we need to do. So if we decide this is not something today's implementations would be able to make use of very much, then we may want to reverse this.
Go ahead, Christian.
On the topic of the authority anomaly, I'd like to add that I think that there is probably a better solution that keeps it keeps the complexity more in the conversion between URIs and CRIs and simplifies the handling of the CRIs. But I think that's best demonstrated when I have my implementation ready to that point where I can show a diff between those two. And that's basically a promise for an implementation review.
Yeah, this version here has the advantage that there is no special casing in the resolution rules, except that you have to set something from true to null in a certain case, but you don't have to juggle the array of path segments in a different way depending on the specific case that you are in. So that's why I like this one here better. This was pretty easy for me to implement. The other one that has been in there before, signifies the lack of a leading slash with a null path name component, and that this is completely monkey wrench to the resolution algorithm. So you have to change the whole resolution algorithm to do this right.
I think the resolution algorithm wouldn't need a special case, but that's probably better taken offline with an implementation.
Let's throw our pieces of code at each other and then we can decide which one is nicer.
Thank you, Karsten. So next step is really getting this implementer reviews so that you can proceed to the next and final step, hopefully. Okay.
Any more questions?
Thank you, Karsten. Then it's up to Bill with Dynlink.
Okay. Can you first see me and hear me?
Yes, very well.
Okay, thank you. I'll now try to share the slides and
should be coming now.
Yeah, it's coming. Just a second. It takes a while to scroll it.
Load it.
Is it working?
Yes. Go ahead.
Okay. Hello, everybody. The next few minutes is basically an incremental update from the last month's interim meeting in core, where we were discussing just the DynLink draft. And the title here is DynLink and conditional attributes. So this is going to be discussing 2 drafts instead of 1. And I hope to take just a few minutes. Okay, so a bit of history. DynLink version 13 has been split into 2 working group drafts. And this was done after discussion with the authors and the area director and also the chairs. So now there are 2 drafts, the original DynLink and then a new draft called core conditional attributes. And obviously both drafts will evolve, and they will continue to incorporate all the feedback and reviews and so on and so forth. So today's presentation is mostly about why this happened, and also perhaps just a quick delta from the last meeting. Okay, so this slide would not be unfamiliar to those who are in the last interim meeting, but just to reflect on this, DynLink has essentially 2 parts. Or shall I say DynLink version 13 had essentially 2 parts. The first part of DynLink focused a lot on the core observe mechanism and how we can provide conditional attributes. The second part of the draft focused on the link bindings themselves. So what is a dynamic link? How do we use it? How can it be recorded? How can it be addressed and subsequently updated? So these are 2 parts of the draft, and they were rather distinct from each other. And what we did was that we took the adverb within, basically took the part that is on conditional attributes, put it to 0, and then took the remaining part of DynLink, and then that became DynLink version 14, and both were now submitted with an informative reference from conditional attributes towards the DynLink 14. Why was this done? There were basically 2 things. Firstly, conditional observed attributes have been available and ready for some time. And the section on link bindings, so the description of the link bindings is okay, but then the binding tables is still under development, and specifically because the way we are expressing relationships is not that good. So there's a lot of work to be done there. So the other part of this is that we have other SDOs that are depending on this draft. So LiveM2M has a dependency on DynLink, and this DynLink dependency is almost exclusively in the, or I should say actually exclusively in the conditional observed part, and not on the link bindings. And the work on the conditional attributes is almost finished, so which basically means that separating them into 2 drafts would allow the conditional attributes draft to move forward into an RFC very quickly, and that will solve the resolution towards LiveM2M. Then that's basically the history. And then now what is in conditional attributes? So this is just a delta to what has happened from the last interim meeting. So firstly, thanks to the core chairs for setting up the GitHub. The draft is already now available at this address, and then also I've transferred almost all the issues that were common to DynLink. So the ones that have been specifically on conditional attributes are now in the GitHub repository as new issues, or rather, I don't know, transfer issues. I guess they are new issues, but essentially the discussion has not been lost. What else? There will be a section on the impact from possible presence of multiple proxies. The discussion that we have been having says that this will be put into the implementation consideration. There will be text for possible security considerations added to 0.1, and then there will be other things done for 0.1, basically just to update the reference code, basically to think about how EP-min, EP-max work. I think we have introduced a couple of new conditional attributes. Then there'll be small other changes. And I think, Alan, if you're online, you're there. So there was a discussion also on the mailing list just a few days ago regarding IPR disclosures. So that will be done to conditional attributes, I think. So if Alan, if you have any kind of input on that, let's just go there. Okay, Alan, you're on the queue.
I'm working it, doing my best to get it moving the right direction. I'll let you know if when I get confirmation that things are moving. You know how sometimes these things take a little bit of time. But Bill, I just wanted to say thanks as well. I think this is great separation. I know I've got that action to provide some examples, but yeah, it'd be great to get that done quickly, and then we can move forward. So thanks.
Right. Let's capture all the discussions that we've been having in GitHub about all the corner cases like pmin being equal to pmax and things like that. And then we'll put them as examples so that there's more clarity. So that's I think these are the small changes necessary before the draft is ready. And obviously, please send reviews to this, and then we'll be ready for working group last call. Okay, I'll move forward. If the slide changes. Okay, right. So DynLink itself. So moving from conditional attributes towards DynLink draft. So the core DynLink draft is obviously now a lot more concise. There were shortcomings seen with the calling format, and that has been a key sticking point. We had several ways where we could try to describe this. None of them have been that ideal. I think Christian had a lot of input on this as well. So we'll do some exploration. I think probably Coral would be something that we'll be looking at. And so DynLink 15 will basically do that, and then we'll try to include. So the original DynLink draft had a lot of examples, but they were most on the conditional attributes, not so much on how DynLink is being used. So I think this is important now to address that DynLink version 15 should have some examples and use cases. I think that's all I have. If there are any questions, we could take them now.
Thank you. Any questions for Bill? Okay, if no, I think the next is Christian.
Yes, good. Christian, do you have a question, or are you just going to the next presentation?
No, I
he's
was
asking
reacting
for-
to Marco's. Next is Christian.
Okay, good. Do I have to give up slides?
You,
Okay,
you need to give up
all right, good.
on your
Excellent.
side, yeah.
Hello,
No,
Christian.
Christian should get it.
So, protocol indication. Let's hope it's now with a good. Okay, the resolution is still bad. I hope you can see what I'm doing anyway.
It's readable to me. I can't complain.
So, what I'm talking about here is a draft that is set out to resolve a long-standing issue that was worked on by Bill and others before with a new approach. But to get into what this is precisely about, I'll have to do a quick run through history of co-op schemes. So in the beginning, there was a golden age of 2014. We had RFC 7252. Everything was over UDP, and everything adhered to the best current practices, and nobody had to fear the reviews. Unfortunately, when co-op over TCP came along, things were a bit controversial on whether this needs a known scheme or not. There were revisions that had it, there were revisions that did not have, and there was a lot of unhappiness still in the no objection ballots when RFC 7323 was finally accepted. But it's not like this was not known to be a problem before, and even back in 2014, Bill summarized the situation of where we can put the information that distinguishes which co-op transport protocol to be used, where that could go. And what was finally picked was the first line, the scheme line. You see, none of those are perfect. Scheme has one particular downside. Nothing had fewer, so this was a good decision. But the one thing that still sticks around to date is the issue of URI aliasing. So we have different URIs for the same topic. And if you look at the example at the top, in most cases and with most devices, if you see the left and the right URI, you can assume that both is about the same coffee machine. But we have no terminology to tell that. And when URIs like that are announced, the application has to make a choice. Do I advertise as CoAP S and CoAP S plus TCP at the same time? Then my user might see 2 coffee machines and there might be duplicate entries and caches. Or do I only advertise one as the canonical URI? And then the application has no way to switch over to TCP if it has the capability to do so, or might not even be able to connect. For there is no mandatory to implement protocol. So if you get a CoAP S URI and your implementation only has CoAP over TCP, that server might provide another transport as well, but you can't know that without any indication. And this is precisely what CoAP protocol indication, transport indication is now about. Before I get to the solution proper, let me briefly point to 2 tools we have. We have resource metadata that we can sprinkle over our discovery results and that we can add there. For reasons of efficiency, this should really not happen on a per resource base because the device might have 20 resources, and if we advertise the TCP protocol on each of those, we double the size of the look result, which is definitely not desirable. And another thing we have in CoAP is very cheap proxying in terms of implementation and in terms of difference between whether the proxy is used or not. So if we indicate, if we want the difference between a request and the request being sent over proxy is literally just one option with 5 bytes added that says, and send this, and this is a proxying request, and that's the scheme. Combining that, the solution that I propose to the issue of URI aliasing and discoverability of resources is to treat the alternative transports more like proxies. This is not ruling out the way they are used today in that both URIs are valid and are sent out, but it is providing a way to advertise them without even incurring the additional URI aliasing. And that happens by advertising a link from the, you didn't see my mouse, do you? That's the second line, by advertising a link from the root of the host to its CoAP over TCP version, which might even have a different port number and might possibly also be available on a different IP address, say if there's IPv4 and IPv6 involved, with a relation that states there is a proxy for the actual resource over there. And then what the client can do is to either ignore that, or it would just open that connection, indicate with that 5-byte option that please proxy me to that same host, but on the CoAP side, and then this is all really requesting the same resource. And on the server side, this is not adding any complexity in the implementation. It looks like, on the first glance, it looks like, yeah, you're really adding a proxy in there, but what you're actually doing is take this proxy scheme option, which is mandatory, which is critical, and if there is no URI host option, which you would need to process anyway, and the proxy scheme indicates that this is another scheme that you support, just ignore it. And that's all there is needed in an implementation. This enables the information, this enables informing the client, and it also creates no additional URI aliasing. Of course, this 5-byte option is something we don't want to send for every request. So one option explored in this document, and I'm pretty sure we can't do this in all cases, but we will probably be able to do this in very many applications, is to say that this proxy is really not even looking into the URI host and the proxy scheme field. So when you send your request, you can just do away with those few bytes, and then we are per message on the same efficiency as we've always been. But there's an explanation for how this happens, and it does not create and it's transparent to proxies, and everyone can know that these requests all go to that particular resource. How this interacts with proxies that are not on the same host is actually pretty straightforward, but I won't go into the details here because that's probably better for hallway discussions unless someone asks about it later on. There are ample security considerations for the document, but actually what it says is, yeah, it's a proxy, deal with it as you're dealing with a proxy. It needs to be suitably authenticated. That's very simple for OSCore, because for OSCore the proxy is not trusted, so it's just a matter of, do I send my traffic over there or not? It's a bit more problematic on the DTLS side, and I could really use some input from people that have experience with proxies and DTLS on how these things are done in realistic scenarios. Right now, I'm outlining two options in the draft. That is either if in the simple case the proxy just has presents the same credentials on both transports, but there are corner cases where it's not that simple, and I'd like to understand those better. So this is where I could really use some additional input. The gist of all this is it can probably be done quite simply. We don't incur all of those bad things that we've seen in previous discussions where a lot of new URIs show up for the same resources. And yeah, with that, I'd like to go over to questions, comments, and all the rest that follows with that. Thank you.
There is, in fact, a question in chat from Brendan. Under what circumstances does my IoT device need to care about the elements of a domain name? Isn't that a DNS problem?
Sorry, just to clarify, that was about the previous presentation. I've been thinking about it. My apologies, It doesn't apply to this one.
No problem. Karsten mentioned on the chat that the scheme is only one variable and the IP address is another. If that is related to this, and I can probably, I'm not sure which slide best to go back to this, but it really works for both. So everything that is identifying the connection from the IP address down to the protocol, and possibly even kind of in the HTTP case, we have different versions of the protocol that for us would even have different schemes. All that is part of that proxy information and can be swapped around at the same time.
Yeah, I think that's really a beauty of this proposal, that it does solve the IP address rollover problem together with the multi-scheme problem. So the only part that we really need to understand is what exactly are the security properties of a resource directory or a well-known core, saying something about a node, and the client blindly following that.
What makes it a bit easier is that all that information, it's easily possible to obtain all that information from the origin source. So you can get these statements from a query to well-known core, and then you get it from the ultimate authority that says, if that host wants to be talked to through that protocol, then so be it. For when this is announced over a resource directory or any similar advertisement, then yes, this can be used to redirect traffic. It cannot be used to change the security properties, but there can be traffic analysis on this. But then again, that source where you get the information from is typically the source that sent you over to that other place in the first place. So they could just as well have sent you anywhere else. There are issues to be pointed out, but I think that pointing them out is also about as much as we can do, as long as we don't have things like Coral signed in fragments and all those things that can later augment this. And I don't think this would need to be a showstopper here. just switching to the backup slides in case this this elicits some other questions. But
We have Bill in the queue.
yeah, Bill.
Okay, can you hear me?
Yeah.
Okay, hi Christian. Firstly, thanks for doing this work. This is really good work. Thank you. And I think transport or protocol indication is a much nicer title than protocol negotiation, so it's much more accurate. I have two comments. The first thing is that going through this presentation, I think that you're coming to the same problems that we did when we started the protocol negotiation. Firstly, are we doing protocol indication, or are we doing proxying? And this is a compromise that you might have to look at quite carefully, because what is this mechanism trying to achieve? Are you trying to find a new transport, or are you trying to find a new URI that you can serve the same resource under? Which basically means that if you have a proxying mechanism that essentially could represent the same transport with a different URI, how do you handle that? And secondly, you might have the same situation when you are looking at secure transports and insecure transports. So, for example, CoAP-S with UDP or CoAP with UDP. So these are things that we need to look at. So that's my first part. And the second part here is that generally what we needed to also understand is whether we have any kind of priority mechanisms where the CoAP client can indicate to the server, or the server can actually indicate, or the origin server can indicate to the client whether a specific transport is preferred over another. So these are issues I think that would be useful to address in the draft.
Okay. I'd like to briefly answer to the first question, which I hope I got right here. This is not about getting a new scheme for an existing transport. It's more getting a new transport for an existing scheme. So you ideally a device can, especially a device that does not want to produce any more URI aliasing, would advertise one single transport, which, if there is no other information about how to connect there, can still be used as it is. And then the additional proxy things are just additional transports, but they are still used for the same URI. And this is also playing a bit into the, and this is also providing one answer to the priority issue. That is, when by picking the canonical URI, the server automatically picks one that clients would most likely use, especially if they are unaware of this mechanism. So there is, in a sense, one distinct transport already, that is the one indicated with the that is indicated with the URI. Now, I suggest this will in many cases be CoAP without any, or CoAP-S without any additional kind of over UDP, but that will be an application choice. As for priorities, I don't see. As for further priorities, I don't see why this can. When this should be easy to pack into the link by indicating some kind of numeric priority. But then again, these being absolute statements, it's like there can be a priority, but what does it actually mean? I mean, the client might have its own priority. So in the end, the client will have to choose, and we can probably provide something that will guide that client's decision if the client even has a choice. But my guess is that in most cases the client will find one that it will prefer and just pick that one. And if that's really a no-go, then the server will probably not advertise it. Did I miss? Yeah, and the point on security, that's a tricky one, because that's one that is behaving quite differently on CoAP over DTLS and on OSCORE. And I think we don't have a good view on the whole whether the CoAP URI is even kind of the best choice, for example, for OSCORE, because where does the indication to use OSCORE come from? Or on the other hand, what does a co-op as really mean? Does it mean you should rely on the host name to come from the PKI, or does it come from the application's security requirements anyway? In which case, why do you put the S in there in the first place? So that's something that will need a lot better understanding of when to use which security transport. And I hope that by phrasing this as in terms of whatever you pick for the alternative transport, just use this for as requirements, just use this for the proxy as well, we can resolve this issue without resolving that issue. Which doesn't mean that that issue doesn't need resolving, but having things compartmentalized should make things easier. Looking at the chat, is there anything?
Not about this. The discussion on href continued.
There's a note on DNSSD. I'm not sure whether this belongs here. DNSSD is a mess. I won't make any comment on this, but see the footnote on the slides.
Okay, thank you, Christian. And I encourage you to continue this discussion also on the list if you prefer forking that into the two main subtopics raised by Bill also.
Yep. Thank you.
Thank you. So next is John.
Thank you.
We see your slides.
So, yeah. This slide is meant to illustrate amplification attacks using several responses to a single request, which this presentation will be quite a lot about. It will be quite quick, so if you want more information, please read the draft. So during the IESG review of echo request tag, the security aid is suggested to also publish draft Matson core co-op actuators as a background on the different attacks that motivating these new mechanisms. So we the authors agree, and we have resubmitted the draft as core co-op attacks. We've also expanded it with a new section on amplification attacks, which is already echo is one mechanism to validate an IP address, but the echo request type document does not provide any additional requirements on amplification protection. Our initial, at least, intention was to publish core attacks as an informational RFC, but depending on the later discussion, that might be discussed. We think during this work, we realized we think that core needs to discuss amplification attacks and probably straight have more hard requirements on how to mitigate that. Co-op amplification attacks have gotten quite a lot of media attention in the last years. Here's a list of just what I found. There are more. So in an amplification attack or distributed denial of service, the most important metric for mitigation is the amplification factor or the anti-amplification limit. It's the ratio between what the attacker sends and how much data the target receives. And amplification attacks are often used with IP spoofing, which co-op NoSec is vulnerable to. The map here shows the number of open NoSec servers in the world. They're concentrated to a few countries and implementations. And you could argue that they do not fulfill the requirements in co-op, but the requirements are quite soft. So the most simple amplification attack is that you send a single request, you get a single response. If the response is 8 times larger, the amplification factor is A. You can increase the bandwidth by sending more gets, and if you're really advanced and have the ability to put or post, you can also increase the amplification factor that way. Observe makes things much worse because a single request results in here n, a number of responses. So the amplification factor is an. And an attacker can register the same client several times by using a different token or a different port number. If you can post to the resource, you might trigger notifications. And the new addition, conditional attributes, make things much worse, because then you can request that your target should have a notification every second or 10 times every second at least. Multicast or group requests also make things worse. Here it's not a single service anymore, several responses, it's several servers sending a single response. So if the number of servers are m, you get a times m as an amplification factor. Additional complication is that a single server typically does not know the number m, the number of servers. And then you can combine multicast and observe, and then of course you get both these factors n and n. We think there's a need for harder requirements. The requirements are quite soft. They are should, not must. COAP does not define what a large amplification factor is. There's just some example where 100 is likely large and 10 is probably not large. This is further softened by if possible and generally in some of the documents. There are several documents here I'm talking about. Observe is a bit more strict. It has must, but it does not say when this must apply, how many messages you can send, and it also says that you must send confirm and receive an acknowledgement, and these acknowledgements can be spoofed. Recently, IETF has published QUIC, and QUIC has a very strict anti-amplification limit of 3 times. So a server must not send more than 3 times what it has received before it has validated the address. And in COAP, you can validate the address by either using a security protocol or the newly standardized echo option. Denial of service is a problem. It tarnishes COAP reputation, and I think core should at least make sure it doesn't get worse. We can probably not fix all the existing implementations. This needs absolutely to be done. We think this needs to be done to the core document 7252. Multicast is a little bit more hard, and I don't know exactly what these requirements should say. I think QUIC is a good starting point, but then I think everything can be discussed. Then the question is, if you agree on that, where should that be? Should it be in the echo request tag as already shipped? Should an update of 7256 be in this document, the core attacks, or should it be in another document? So I basically have three questions to core. Do you agree that with the security agents and the authors, it would be good to publish this? Do you agree that it's good to strengthen the anti-amplification limits? And third, where should such strengthened anti-amplification limits be published? Maybe publishing in this seems the simplest. I think that's it.
Go ahead, Carsten.
Yeah, I have several comments here. One is a technical comment. So QUIC gets by with this hard limit because they can simply inflate the request. So if they need to get more data, they just send you a larger request. And that's maybe not exactly what we would want in a constrained environment. So I think QUIC is not exactly the role model we want to use here. I think what we really should be doing, because this is not a problem that can be solved with a simple rule like the quick rule, write up something like a BCP that tells people how do you avoid being a valuable target for an amplification attacker. I think there are not so trivial answers that this document needs to provide. So it's not something that we can cover together in 5 minutes. And I think we have to avoid overloading our existing documents with this, because we want to get documents out and make sure that people don't put in new stuff there that hasn't been discussed, that creates problems and so on. And I think it needs to be a BCP because really there is no hard answer that you can make here. This needs to be explained, what needs to be done. Multicast is hard, and observe is obviously something that could benefit from a few clarifications. It would also be nice to address the spoofing situation there, and so on and so on. So I think it would be really useful to have this BCP, but I think we need to make sure that this is developed in such a way that other documents are not stopped in their tracks.
Yeah, agree. One question is maybe if we can publish multicast observe and conditional attributes with a Pmax value, which quite obviously makes the denial of service worse. But a short time before that, BCP might be to add additional security consideration requirements in these documents.
Well, conditional observe is something that is out there today. So I don't think that publishing or not publishing will change anything here. I mean, this is essentially an application protocol. Of course, there should be some stern words in there that people should be following what 7641 says, but yeah, it's one of many applications that people put on top of CoAP, and I think we really have to describe these applications instead of, again, loading up every single document that we ever publish again with the same the same set of sentences that people have to be careful about amplification checks. That's already in 7252, and unless we can give specific advice, we really should shut up here.
Yeah, I totally agree about centralizing the best current practice recommendation guidance and not spreading.
Marco here, an option can be addressing especially the points 1 and 4 in your top list already in this document, actually, because you're giving the background and discussing the problem, and point 1 and 4 are really on CoAP and observe, let's say on one-to-one communication, while points 2, 3, and 5, they're about group communication, and they can go possibly in group bis, which is already updating CoAP and observe for other reasons.
Well, that's exactly the inverse to what I was recommending. So again, if we smear this problem over all documents we ever generate in this working group, I don't know what to say about that. Let's do a BCP that really addresses the problem, that can be referenced in RFPs, so people can say, folks, do you use CoAP? Do you actually follow this BCP? And so on. That's a useful way to take the problem, to actually have an effect. And the other one is, yeah, let's do a few more RFC 6919 keywords in our various documents, but it's not helping anything.
I like the idea of a BCP. Sounds like a good idea to me.
Any more feedback? Okay. Thank you, John.
Can you hear me? A question
Yes.
for Karsten. So just trying to understand why is it a problem that we also, I mean, we have both a BCP and also bring up the problem in the various drafts which we are working on?
Well, bring up, of course, point to the specific section in 7252, which tells you that you have to be careful about application attacks. Trying to come up with a solution to the problem. In every document that happens to touch CoAP in some way, that's not good. So if your draft has something in it that actually changes the problem, yeah, maybe it makes sense to actually address this. But mostly, I think, really point to that BCP.
But that so I mean, what things that really change is, for example, then the group CoAP group com and the conditional attributes, and that actually it's something that we should bring up in those drafts.
Bring up, yes. Try to solve more.
Yeah. Okay, I understand. It's good. I agree.
Jaime, you have your hand raised.
Question for the authors. I'm wondering, is there any documented solutions to UDP attacks, DDoS attacks based on the underlying UDP protocols? Because that's at the end of the day the problem, right? So I don't think I mean, the specification can only guide. We cannot really propose solutions unless there are solutions, because I'm not aware of any.
I'm not aware of any. I know that DTLS and Quick do their own solution on top. So if there are solutions there, I don't think they are used, at least, or implemented.
Okay.
Okay. And we were talking of that, so we jump to group combis. In fact, all right. This is an update to the group combis document. And as a recap, the idea here is to replace the old experimental 7390, formally obsoleting it, and at the same time updating CoAP and observe when used for group communication. It has in scope a number of things. So CoAP used by default now over UDP IP, the latest functionalities for CoAP developed over the years, caching model, and now also secure communication with group of score, among other things. So this update was mostly about a number of points discussed at the June interim meeting, and most of them were about caching model. And the focus on this document was agreed to remain only on caching from the origin client point of view. So we are basically following the original rules from CoAP with a little addition. We are allowing a case where the client may not send to the servers in the group request, but entirely serve it from its cache, only in case the client has a full up-to-date knowledge of the group membership, so of the servers in the group. And for each of those, it has an up-to-date response cached. How to possibly achieve that is out of scope, but you need this condition to verify to possibly do that. That's for the freshness model. For the validation model, we introduced in previous versions a new option that was judged a bit too complicated. At the interim, we compared and discussed over 4 different alternatives. And in the end, we converged for a proposal from ESCO about using basically the original ETAG option, pretty much in the same way for the servers, just giving a bit more homework to do for the client in case of collisions or value conflict in the tag value offered by the different servers in the group. Otherwise, it really looks like using the same old ETAG option, and it's friendly also with legacy server that would not support it and are free to ignore it. Yeah, other things related to caching were actually moved out of the document because it was about the caching model on the proxy that built on the one for the origin client, but of course introduced a number of additional features and checks to do. So all this was considered a bit too specific for this document, and it was moved out, agreed to move out to a more appropriate document that we have actually for proxy and group communications, which is GroupCom proxy, and that is not in the agenda for today anyway. But all this kind of content was moved there. And then we got a review from John on version 4. Thanks a lot for that. It was basically 5 points. We think we addressed 3 of them. So transporting co-op with UDP over IP multicast is just a default transport now. You can go for different ones. And similarly, Grupo Score is the default choice for security in the group. In principle, more can come and be used at some point. And we also adjusted the text that was raising too high expectations for a reader about what you can achieve using Grupo Score and the echo option against amplification, denial of service attacks. So you can have, to some extent, a mitigation against them, especially with echo, but you can prevent the problem altogether, also as you shown in the previous presentation. Also building on John's review, we still have to clarify more in detail how we are updating and obsoleting where, though we already have some text on that will improve. And on the biggest point about amplification attack, we added a new section exactly about this. So it's not complete. We plan to revise it, also considering the recent submission of co-op attacks. But it should be good enough for first reading to get more feedback and more input, especially from John and more. Also, following a discussion on this already at the interim, we are stating stronger than before, I hope, that we really don't recommend the no-sec mode. It's strongly discouraged, but we are mentioning examples where if you really know what you're doing in particular cases, it may still be acceptable or even the only choice, especially for a just deployed device that is trying to discover what it surrounds it and try to get in touch, for instance, with an entry point like a resource directory. Karsten?
Yeah, I think that's again one of those places where it's easy to say the no-sec mode is not recommended. 6119 has this additional phrase, but we know that you will do it anyway. So that's not the useful part. The useful part is to point out that the way this is used needs to do some things like rate limiting or whatever is needed to make the application of the no-sec mode safer. And yeah, there's also block 2, there's echo. There are many ways to make sure that it cannot really be used for amplification very well. And of course, our biggest protection is that multicast doesn't work on the internet. So we can, I think at this point, rely on this a little bit. But I think the important thing is that no-sec is not something we can deprecate in any way. It will still be needed for specific applications before security can actually be established. In the dispatch meeting, I don't know if you were there, there was an interesting discussion. In the SDP space, there is something called SDS, security description, which is, well, yeah, a weird way to do security. And people wanted to deprecate that. And yeah, no, you cannot do that because there are no replacements for that in specific areas of application. So you can just guide people to use DTLS whenever that's possible. And then there's SDS out there in case you need it.
Thank you. Yeah, some other little addition. We included also a new small section that ESCO proposed and was also quickly touched at the interim about giving a bit more high-level description of what security you can have on different communication legs if you have a proxy. So you should really go end-to-end. For sure, if you have a forward proxy, you should do the same if you have a reverse proxy. We are kind of admitting a case with a reverse proxy that is really totally trusted, where security can be hop by hop between the client and the proxy, and then the proxy can use GrupoScore instead between itself and the servers. But this stops at a high-level description, and possible further details are, again, for the GroupCon proxy document. We gave some more clarifications on some options where some more work was needed, and we produced an open point about terminology that maybe we can quickly check today here. We are using now consistently backward-forward security. Esco was wondering if we can switch to backward-forward secrecy. I'm a bit worried that that forward secrecy can be confused with perfect forward secrecy used in different contexts. But I could see used both terminology in the literature about group communication anyway. Is there any input opinion from anyone about this? John?
You should, yeah. It's very good to explain what you mean. Like, compromise of key X does not lead to compromise of key Y or future keys, or yeah.
We have an explanation, and we don't mean that.
Yeah, but I think you should explain what you protect against and not. The informal dictionary on IETF security terms says that it provides a definition, but it also says this area is a mess. The expert disagrees. Yeah.
Yeah. Thank you. Yeah, and that's it. We plan the next version for sure, completing addressing the comments from John. We have a few still open issues on the GitHub and 3 new ones added today by Christian. Thank you. Still have to do final tests on advanced functionalities with blockwise for the little you can do in a group. So hopefully the next revision can be considered for working group last call. That's it. Any more questions? Okay. Then we can right away switch to GrupoScore. Right. This is instead a much more consistent update to the GrupoScore document. Just to give a very high-level overview, this was about introducing a proposal from Christian about recycling in the same group also group identifiers, addressing a big point from Ben Kaduk about the use of identity public keys both for signing and Diffie-Hellman, and then a number of changes, especially to the group mode, thanks to comments we got from John in the past months. So as to the input from Christian, we were forbidding reassigning the same group ID in a group from the group manager, because that was going to break the security of very long living observations. And as a reminder, the group ID changes when the group manager rekeys the group and changes the key material. There's actually a fix for that to enable a perpetual recycling, and it just requires some more homework for the group manager. So the group manager for each group member has to remember the group ID that was used in the group where that group member joined the group. So we call this birth GIDs. And if the group manager decides for any reason to rekey the group, it has to notice it. By chance, it is going to assign a group ID that is corresponding to any of those birth GID. If that's the case, it has to evict from the group also those guilty, very old group members that eventually will join the group again, dropping their observations and solving the problem we had in the first place. So bottom line, it is now possible with this addition to reassign the same group ID in the group safely. And then we had the big point from Ben. So to recap, in the group, you can use both the group and the pairwise mode, which requires to produce symmetric pairwise keys. And for that, we were using public keys in two ways, both for the main signing in group mode and for this key derivation. This is not exactly a common practice, so you may do that, but you need to really know what you're doing and prove you're not breaking any security property. Before, we were building on pretty well-known paper in reference 5 here that was providing a proof about this, but not in a so specific context aligned to GrupoScore. So we ended up producing a proof specific to GrupoScore that was provided by Erik Tormarker from Ericsson. Thank you very much for that. You can find it in the reference 6 here. And the proof required a little adaptation to the way we derived symmetric keys. Basically, we need to provide also the public keys of the two endpoints in the derivation of the pairwise keys. But after this little change, it was possible to produce a proof, which actually shows that if you are using ECDSA signing keys, the original proof actually applies to GrupoScore just as well. If you're using EDDSA signing keys, well, then you really need a proof of its own that was provided. So we don't have the full proof in the draft, but it's presented at a high level in the security considerations. And we also added a considerable amount of text to better document the conversion process that you have to do from Edward to Montgomery coordinates if you use EDDSA keys. And then we have the points from John. Most are common to GrupoScore, others are specific to the group mode. So this is general, and it was about the need to say something at all about the format of public keys to use in the group. And it has to be a format such that it includes not only the key, but also a full description of the public key algorithm and possibly related parameters. And of course, it can carry additional metadata like the key subject. So good formats to use that we mentioned in the draft now are certificates of different kinds, CWTs, and a protected CWT claim sets like the one in the example here. But of course, one group works in one way and every member has to use a same format in the group. And the group can work in one way, but now it is one way out of 3 possible ways, not 2. So the group can work in group mode only or in pairwise mode only, which is new, or in both modes. And a group member has to know that latest when joining the group. And enabling these alternatives really require to hardly decouple the modes and to revise the information included in the security context. So the one in the figure taken from the draft, again, builds as a delta on top of the original context defined in the score RFC. But I have highlighted in green here the new elements we have added in this revision. So yes, we have involved also the public key of the group manager. It becomes clear why in the next slide. We indicate specifically the signature encryption algorithm. So the algorithm used to encrypt the message in group mode when a signature is in fact also involved. We have added a new common group encryption key derived like other common keys in the group, which is used more on that later to separately further encrypt the signature in group mode. So just to recap what we are supposed to use in what mode. In group mode, you encrypt the message with the signature encryption algorithm, then you sign the ciphertext with the signature algorithm, then you take that signature and you encrypt it somehow using the group encryption key available for that. In pairwise mode, you encrypt the message using the AAD algorithm, which is not shown in the figure because we use the one already indicated in the baseline score security context. And you use the pairwise key agreement algorithm to derive the symmetric pairwise keys to use. Now, similar updates had to be done in the external AAD. Now, we have specified the additional algorithm entries from the common context here also in the algorithms array, from which we have removed a number of elements that were descriptive of the algorithms and their parameters. That was just redundant because now all that information will be in the public keys in the first place that come at the end of the external EAD, as you see. So there you find, as a serialization of the format used in the group, the public key of the sender, generating, protecting the message, and the public key of the group manager. It is useful to have that public key of the group manager there too, to have a full, complete description of how the group works and to cheaply prevent a possible group cloning attack that we found, although it's pretty hard to mount, so to say, but this was a cheap solution to prevent it by construction altogether. And there is a discussion on the details in the security considerations. I mentioned before now that in group mode, we are now also separately encrypting the signature to not confuse the steps. This is the order. You encrypt the cozy plaintext first, you sign the resulting cozy ciphertext, and then you separately encrypt that signature. As a result, you achieve group privacy because now an adversary is not able to track anymore a user across two OSCOR groups unless the adversary is, of course, also a member of both those groups. So how is the signature encrypted? It is stored with a key stream, which is generated with an HKDF construction, the same one used to generate keys, taking as input the common group encryption key I mentioned before, and some information from the message in question. So the partial AV of the message and the sender ID of the partial AV generator. Without overthinking this, it is the same rationale and thinking that OSCOR uses for building the AAD nonce, basically. And related to signature verification at the reception side, we also added a pretty strict rule about verifying the signature first. And if that is valid, only at that point continue with the decryption of the ciphertext. Right. Then we also wanted to admit in group mode only encryption algorithms that provide only confidentiality and not integrity protection. So basically, they don't have a tag. And there's a number of these that are going to be at some point registered in COSI. From an integrity protection point of view, you are still fine anyway, thanks to the presence of the signature. And the good thing is that, of course, you reduce overhead that could have been unbearable in some use cases that otherwise would have to deal with both a tag and a large signature in every group mode message. I think John mentioned especially cellular networks in a mail message on a list at some point. So integrity per se is fine. The catch is that without a tag, with the previous construction, group members would become unable to fully, faithfully assert the group membership of the message sender, because they may retain its public key and never know if that message has left the group. They were not informed about that. So to fix this point, we actually made the key management policies stricter. And basically now, if a group member leaves the group manager must rekey the group. And when doing so, it must inform the remaining group members about that leaving node. It basically has to inform the remaining group members of invalid sender IDs, especially the ones of the now leaving nodes, so that the current group members can make some cleanup and especially forget about the public keys of the nodes that leave. So as the result, every remaining group member owning up-to-date key material will not have any more public keys of nodes that are not group members anymore. So it will be possible to assert group membership of a sender also in messages in group mode that don't have an integrity tag. Of course, a group member can be unlucky and miss some reking instance, stay behind, and the group manager must provide some kind of recovery mechanism for that group member to catch up and be in sync again. In this document, we are phrasing this as requirements for the group manager services to provide, but not in detail how it has to. But the suggested and recommended to use group manager that we are defining in ACE actually defines in details how this can be achieved. Yeah, other easiest things. We added more guidelines for external signature checkers and how to handle with some possible corner cases when they do their job. We removed some appendices that became moot due to the changes we've made, or they were including content to not be considered secure enough anyway. We had made a good revision of the security considerations in the light of the updates I showed in the previous slide, especially about the group mode and the new proof from Eric. So that's it from this version, and we still have to improve some parts of the security considerations. I think John also wanted to mention some more on some properties that we are fulfilling, just with a better analysis. And we need to double check that the few issues still open on the GitHub can actually be closed, because they are mostly addressed, I believe. So we definitely expect one more submission, and if we are really now addressing all those points raised before and no more issues arise, that can be considerable for a second working group plus call. That was all from my side. Questions, comments, anyone? Looks like no. Then I abandon this. Göran.
Any plans on interop testing? I know there's been some testing previously, and when is the right time for sort of what version would you like people to test?
We hope after summer, and well, Richard is updating the Java implementation. I think Christian is also interested. So these two implementations can hopefully be the next ones to interop. I hope it can happen after summer.
Okay, thanks.
Thank you. Okay, so next is Richard, and you should be able to ask for yes.
Right, I hope you can hear me.
Yes.
Good. So yes, so this is the presentation of the draft about combining OSCORE and ad hoc. An update to that. So let me go to the next slide. Just as a recap on what this is about. Basically, first of all, ad hoc is lightweight authenticated key exchanged, which is being developed in Lake. And it has a number of use cases, but the main use case can be said to be keying of OSCORE for establishing an OSCORE security context. And normally, this would take 2 round trips to run ad hoc and then have an OSCORE security context set up. However, the thing that this draft does is that it combines ad hoc run over COAP with OSCORE. So basically, we combine the ad hoc message 3 with the first OSCORE protected request into a single that we call ad hoc plus OSCORE request, which transports both the actual OSCORE request, protected OSCORE request, and ad hoc message 3 together. And the point of doing this is to achieve a minimum number of round trips time for setting up the OSCORE security context and to complete the first OSCORE transaction with that context. Right, and yes, so let me go to the other slide. We have our kind of overview there. So here is the plain way, let's say, when typically you run ad hoc first to see ad hoc message 1, ad hoc message 2, and then ad hoc message 3. And not until ad hoc message 3 can you actually run OSCORE and send the OSCORE request and get the OSCORE response. However, in the combined way, you can see that the client sends ad hoc message 1, you get ad hoc message 2 from the server, but now you, instead of sending only ad hoc message 3, you send ad hoc message 3 plus the OSCORE request. And the key point here is that after the client has received the ad hoc message 2, it can already produce the OSCORE security context. So it's in a position to protect the OSCORE request. And send that to the server already after receiving message 2. And in the same way, then the server will first process the ad hoc message 3, produce the OSCORE security context, and then it can unprotect the OSCORE request that comes together with ad hoc message 3. And here's kind of an overview of the message, how it can look basically. So in the payload, you essentially have the ad hoc message 3 plus the OSCORE ciphertext. And the way we signal this combination is by using a new option, which we call this ad hoc option, as you can see in the options box there. So you have the normal OSCORE option, but you also have an empty ad hoc option that indicates that this is the combined request. Yeah, and then a couple of updates we did since IETF 110. So the first thing we did was that previously we had decided on an option number, or we were, let's say, suggesting in the text to have number 13 for this new ad hoc option. However, we now changed that to number 21 instead, because it works just as well for properties we want, and other use cases may need this lower number 13. And the point here is that the properties we want for this option is that it should be critical, safe to forward, and part of the cache key. But at the same time, we want to make sure that it doesn't have a delta exceeding 12 compared to the OSCORE option, which is number 9. Because then if the option is empty, which it is, that will lead to an option that is 1 byte in size. So both 21 and 13 would work for that use case. And we intend to make a request for early IANA allocation for this number 21, because it allows us these properties, and then, like I said, only 1 byte size then for this ad hoc option, because we assume that the OSCORE option is going to be in the message, which it is. So then the delta will only be 12. And then further than that, we extended and improved a bit the background information about ad hoc itself, just explaining a bit more what ad hoc actually is also in this draft. And this was based on feedback from the IETF 110 meeting. And we also try to keep track and align this draft with what's going on in the ad hoc draft, because there's been a number of updates there. Especially one point was about the connection identifiers. Who previously were kind of these special encoded values. However, now they can be either CBOR byte strings or CBOR integers. So that affected also this work a bit. Other than that, yeah, we improved and updated the examples a little bit. Let me go to the next slide. Yeah, further updates. So one thing that was triggered by this change in the connection identifiers was that we started discussions on conversion between ad hoc IDs and OSCORE sender and recipient IDs. So we started by defining actually a way to convert from ad hoc IDs to OSCORE sender recipient IDs in this document here, in this core document, based on a proposal from Christian. However, after further discussions, that was moved to the ad hoc document in Lake, because it was felt that that should be a core component of ad hoc itself and be defined in the ad hoc related document. And but in addition to that, we also worked on defining a conversion method from the OSCORE sender recipient ID to the ad hoc IDs. And the point here is that the reason we need this is that since the ad hoc IDs can be both CBOR byte strings or integers, there's basically 2 equivalent ad hoc IDs for each OSCORE ID. So in the solution we propose in this document, we need a deterministic way to do this conversion. So we pick either the int or the byte string representation of the ad hoc identifier. Because when you get this ad hoc OSCORE combined request, the way you retrieve the ad hoc session is by looking at the OSCORE option and taking the KID from the OSCORE option. So then you need a deterministic conversion to an exact specific ad hoc ID to be able to pick up the correct ad hoc session. So there can't be any ambiguity. You have to know whether you take the int or the byte string representation. And also the good part about the way we propose here is that you always choose the smallest representation in terms of size. And this we currently have this defined in Appendix A. So one thing we were discussing is if it's worth to move this, in fact, to the document body. that can be a good idea. Yeah, and some open points we have. So one general open point we had was about, is it worth to expand the scope of this document, let's say, because previously we had some earlier attempts to expand the scope. For instance, we had this derivation of the OSCORE security context that used to be in the ad hoc draft, then it was moved to this core draft, then back to the ad hoc draft. And same thing with this conversion from ad hoc to OSCORE ID. It used to be in this core draft, then it was moved to the ad hoc draft. So one thing we were thinking about was to expand the scope of this document, so it's not only about this optimization, about this combined request, but it's more general about profiling the use of ad hoc for co-op and OSCORE. So there, for instance, we already have this conversion from OSCORE ID to ad hoc ID that's already included in this core document. But we had some other ideas on things to include, like usage of this URI compression option. That's a proposal from Christian, so you can indicate the URI using an option basically to reduce the overhead. And we also had ideas about defining information related to web linking. So the resource type ad hoc could be possibly registered in the ad hoc main draft. However, further target attributes covering the applicability statement can possibly be added here in this core document. And basically, any other things that would be considered too detailed to be included in the ad hoc draft, that can potentially be then included in this core draft, and if we expand the scope. And we're very happy to hear opinions or input regarding this idea. And then next steps, yeah, so as I mentioned, we plan to do this request for early IANA allocation for option number 21 for the ad hoc option. That will signal the use of this combined request. And as for the actual draft, we plan to update the text and figures a bit to make it consistent now with the way that the ad hoc draft uses the content format, because it's been changed a little bit since now the connection identifiers are external. The use of content format is a bit different. We want to add a bit more information about the applicability statement, to have information like, okay, does this client and server support the ad hoc OSCORE request, and what ID conversion method does it use? That can be defined in the actual applicability statement. And more than that, you want to update our actual implementation, because we have running code, we have an implementation of this, except it's based on ad hoc version 7. So we need to update that. First, we start by updating our general ad hoc implementation, and then the next step is to update this combined request implementation. And we also would like and need reviews for this document. That's very welcome. Yes, thank you. That was the last slide. Any comments or questions?
Yeah, Göran entered and has now re-entered the queue.
Yes.
Yeah, I think this is. I mean, this is really good work, and it's a lot. Maybe it's a little bit not so so nice that some of the content you produce is actually moved out of the draft. So, but I think it's great that you actually fill in a lot of the details, and I don't have strong opinions where it ends up. That's been, I mean, in the case why things was moved back to ad hoc was because the chair of the Lake Working Group had support in the charter. He said that this information, it sort of belong to the Lake Charter, so it should be in the ad hoc document. So
yeah,
I think those are the type of considerations that may decide where specific content goes. But I'm really happy that you help out and produce all this input here.
Yeah,
So yeah, so everything you have listed here, I think, is worth documenting somewhere, and please put it in this draft. Oh, Malisha, you want to add something?
Please, Malisha.
I would just like to reiterate what Göran said about the scope of the draft. Essentially, the Lake Working Group has a pretty clear charter that we need to produce a deliverable, a solution that is going to key OSCORE. So essentially, the ad hoc drafts needs to be self-contained in that sense that it can work as is to key OSCORE. So the way I see this, based on the points that you raise in this slide here, is that so the core points about keying was core related to the conversion of the connection IDs. They belong to the ad hoc draft, and then any potential optimizations, some essentially compressing URI or web linking. I mean, I guess these belong to the core draft. This is at least how I see the two drafts evolving. Yeah.
It may still be useful that the resource type at least is defined in ad hoc already, where you are defining the media type. So for consistency, the exact resource type can appear in ad hoc already. But
that could be an option, yeah. Okay.
Yeah, so I think it will make sense to have this discussion in Lake also. So, and then essentially that we can decide what is really an optimization and what is the core feature that we need to include in ad hoc.
Yeah, that sounds good.
Okay. But in any case, thank you so much for doing this work, and it's really appreciated. I mean, I wasn't aware where different pieces came from, and I mean, this is really appreciated. Thank you.
Yeah, thank you. Thank you. Right. If there are no further comments, then I move to the next.
Karsten is asking, what is Christian's separate proposal? I think it was presented at an interim.
Yeah, that was this URL compression option, but yeah, it was presented, but I guess to keep it short, it was about using an option to indicate the URI, so you can save some overhead rather than having to say well-known core. You can, well-known ad hoc, you can have an option, very small option indicating to mean the same thing.
Thank you. Okay, you're the next one, so I think you can transit seamlessly to the next.
Yes, indeed, I should be able to. Let's see if I can find the slides. Yes, there they are.
Great.
Okay, yes. So now moving to the next presentation. So this is about, first of all, as you see, we actually updated the title of this document. It used to be called AAD Key Usage Limits in OS Core. However, we updated it now to call it Key Update for OS Core. And that's because we expanded the content with further material about the method for rekeying OS Core. And I will come to that. So just as an overview of what this is about, first of all, OS Core uses AED algorithms to provide security. And there is a draft from in CFRG that defines the certain limits you have to take into account in terms of key usage, meaning how many times you use a key to encrypt, and failed decryption, meaning how many times you use a key and the decryption fails before you need to rekey these keys. And if you do not follow these limits, it would be possible to break the security properties of these AAD algorithms. And I have a reference here to the CFRD document. So what this draft does is look at the AAD limits and their impact on OS Core, including defining good limits for OS Core. And we originally started from assumptions from TLS and DTLS, but we have now revised things based on input from John Mattsson at the April Core Interim, who suggested a bit of a different approach. And more than that, what it currently contains is how you should handle these limits within OS Core, meaning you have to have counters in your security context to count key encryption usage and invalid decryptions. That's what we call these Q and V counters. And when these limits are exceeded on the usage limits on the keys, when they're exceeded, you need to rekey the context. So now number 3 here, point 3, is the new material we added, which is about defining a method for rekeying OS Core. And this is loosely inspired by the current Appendix B2 of OS Core. And the general goal is to get a new master secret and salt that then ends up meaning you derive new keys. So you have new sender and recipient keys. Basically, you renew the keys you actually use for encrypting the data you're sending. And the method we propose here also achieves perfect forward secrecy. Just a bit of overview on the key limit. So what we did now was previously we calculated the limits based on suggested probabilities from the CFRD and DTLS document. But after input from John, we took a bit of a different approach. So basically what we do now is we set fixed limits. So we say that the Q limit is 2 to the power of 20, V is also 2 to the power of 20, and L is 2 to the power of 8. So L here is the max message length in cipher blocks. So we just set these fixed values, and then we calculate what the probabilities would be considering those Q, V, and L values. And here in the table, you can see for these 4 algorithms what our resulting probabilities are. And the general thing to take home, like you see the IA probability, which is the integrity of advantage, which relates to integrity properties, and the confidentiality advantage, which relates to the confidentiality properties. And the general thing to take home from this is that these values with these Q, V, and L, and then using the formulas from the CFRD document, these values we present in this table here should be safe for these 4 algorithms. So if you pick these Q, V, and L as your limit, you should be safe for these 4 algorithms. But then we had a bit of a special study on AES 128 CCM8, because that's the most problematic due to the short tag length. And here we produce a table with multiple combinations of Q, V, and L values to see what the resulting probabilities would be. And you can see here we have highlighted a certain line in red, and that is the, let's say, the optimal choice of Q, V, and L values that provides you the smallest IA and CA probability, considering the values we tried. So one question that comes up here is that for instance, an IA probability of 2 to the power of minus 54, is that good enough, sufficiently secure, let's say? The QA, the CA here is 2 to the power of minus 70, so that should be not an issue, let's say. But again, this AES 128 CCM is the most problematic due to its short tag length. So we had a bit of a special study on that. And then we come into the actual key update method. So basically, we defined a new method for updating and rekeying OS core. It's based on the exchange of nonces, R1 and R2, between the client and server. We have a special update function that derives new OS core security context using these nonces. And what ends up happening is we have an initial current security context you start with. Then we produce an intermediate one as we go through this key update procedure, and eventually we end up with a new security context where the keys have been renewed. And some of the good properties of this solution we present here is that there's only one intermediate security context produced. In comparison, the Appendix B2 in the current OSCORE RC actually produces 2 intermediate contexts. And also in this solution we present, you never change the ID context, while the current Appendix B2 does in fact change the ID context. And other general properties, yes, it can be initiated either by the client or server. It works well even if one of the pairs reboot. There's no issue with key reuse or nonce reuse. And the actual process completes in a single round trip after that when you start using the new context. And finally, it's compatible with a possible prior key establishment through the EDDOC protocol. So whether you started with EDDOC or didn't, you can actually take advantage of the EDDOC exporter in the cases that you started and produce your original context based on an EDDOC run. So this is an overview of updates to the OSCORE option. So basically, we did a number of updates here, but the key ones are that we defined the use of flag bit 1 to extend the OSCORE option with flag bits 8 to 15. That's so we can fit this new flag bit 15. We have to indicate that the OSCORE option now produces, or includes rather, an ID detail. And the ID detail is basically a length and then the value of the ID detail. And this is what we use for exchanging the nonces, actually. And also a key point here is that this bit 15, can explicitly be used to indicate this is a key update message. So there's no ambiguity or confusion that this is a key update message. In the current Appendix B2, there is no explicit indication like that. You can still figure it out through some logical steps, but there's no explicit indication. And here's the general message flow. So essentially, the key point here is that what ends up happening is we have this update function to the right that can either use an HKDF to produce a new master secret, or it can use the adhoc exporter, depending on if your original context started with adhoc or not. And the client will send an initial request protected with an intermediate context. The server receives that request and can unprotect that with the intermediate context. And then the server will actually generate the final context to be used to send a response with. And in the same way, the client will generate the final context to be used and unprotect the response. And all the key for this way we update the context is we simply take the nonce as input. And yeah, then it depends if it's adhoc or you're not using adhoc, but fundamentally what ends up happening is you get new master secret and master salt, which means you have new keys to use. And then you set all these counters for with respect to the limits reset, and you start them from 0 again. Yeah, and some summary. So basically what this document is essentially a twofold update to OSCORE. Because first of all, we have this material about the limits and how you should track and what you should do with in terms of message processing, considering the limits to preserve the security. And then we also have this new method for efficient key update, for efficiently rekeying OSCORE with perfect forward secrecy. And actually, initially, this update procedure was planned as a separate draft. However, after some feedback from the core interim, we decided to put this together into the same draft because it can also make sense that we define the limits and we say, okay, if you reach the limits, you have to rekey. And then the next section is, okay, this is how you can do the rekeying in practice. We also want to look and consider more, especially CCM, if anyone has any feedback on that, on these tables we showed and on the calculation. That's something we should look into further. We also have a lot of open GitLab issues that we will continue going through. And finally, we would very much appreciate reviews both on the key update part and on the key limits part. Yes, thank you. Any comments or questions on this?
Yes.
Yes.
I think this looks really good. So I've been looking through the draft. I watched this from the sideline, and now I've been reading through the draft. And I had a question about what happens. So as you know, the Appendix B is handling the situation both when the client initiates and when the server initiates. And
yes,
then I realized that you answer that in the draft. So I mean, you should tell the others as well that you have a solution.
Yes, it's a good point. I should have mentioned it here. This is the client-initiated version shown here, but there is also a server-initiated version. So both the server and client can initiate this procedure in practice. It's just that when the server initiates it, it's like the client sends any kind of normal request to the server, but then the first response from the server will be the first message of this procedure. But fundamentally, both the client and server can take the initiative to trigger this process. That's true.
So one thing I was looking for was how do you handle Appendix B2? I mean, I assume you want to deprecate Appendix B2 in favor of this method, or what's your view there?
Yes, I would say that currently we have a list of possible ways to rekey OSCORE where we mention like the OSCORE ACE profile and also Appendix B2. But yes, I think, like you said, it would make sense that what we produce here is an alternative that would deprecate the existing Appendix B2.
Right.
So it's not too many choices. Let's say it's just this would be the way to go. This would be like the new Appendix B2 in a sense.
Yeah. So then my final comment is on the. I mean, there is one thing that is not attractive with this procedure, but it's even worse in Appendix B2, and that's that you need to derive intermediary security contexts.
That's true.
And in this case, it's just one intermediate in comparison.
It's only
to
one.
two. Yeah.
Yeah.
So then, if anyone has any feedback on that, but I don't think it's possible to avoid that, because that's basically how you trigger the update procedure in a secure way. It's that you produce a new security context, which only the endpoint that has the old context can use. So I don't know if anyone else has a comment, or you have a comment.
Difficult to avoid, but yeah, definitely. If anyone has any feedback on this, how we could improve this procedure further, is very welcome. Yes.
Kristen, I think that we can't in all situations avoid having the second context, but there might be situations in which it's known sufficiently long in advance that that a rekeying will need to happen to avoid it. But then again, this opens up another code path that might make things more complicated than there comes any good of it.
Yeah.
Mm-hmm. Right.
Well, yeah. No, I know for the questions. I think this is really good. Thank you.
Thank you.
So if there are no other questions, we are on the top of the hour. We would have one more document, but there's no time for this session, I'm afraid. It can be moved to the interims. And by the way, we have scheduled already 4 interim meetings for the autumn, starting from September 15, I think. So see you there. See you in Gather Town. Enjoy the rest of the meeting. Thank you all.
Thank you.
Gather Town.
Thanks.